Hello once again, ladies and gentlemen, and welcome to our virtual classroom. Today we're going to be going over quadrilaterals. Quadrilaterals, which, oops, that's triangles. There we go. Quadrilaterals, which is our 42nd lesson. This is 23-1. So again, today we're going over quadrilaterals. And when you think of the word quadrilaterals, in fact, the prefix quad means four and lateral means side, so it's a four-sided shape. Last week we were talking about triangles, which is a three-sided shape. However, today we're going into quadrilaterals, four-sided shapes. And here's some terminology. Here we have polygon, which poly means several or many, and so polygon is a closed figure with three or more sides. So the simplest polygon would be the triangle, followed by the quadrilateral, which is a four-sided polygon. So quadrilateral is a four-sided polygon. Now, the first quadrilateral that we're going to be going over today is known as a trapezoid. So a trapezoid is indeed a quadrilateral. It has four sides. And in fact, here's an example of one. However, what makes a trapezoid is that it has two parallel sides, or rather, it has one set of parallel sides. It has two sides that are parallel to each other. And what does the word parallel mean? Well, parallel simply means that those sides would never, if I were to extend them out forever, those sides would never touch. So here's another example of a trapezoid here on the side. And as you can see, this side and this side, these are parallel to each other. They would never touch. In this trapezoid that I have here, notice that I have arrows on these two sides indicating that they are parallel. That if I were to stretch these out forever, they would never touch. So again, if you have a quadrilateral with one set, that's two of the sides being parallel, and that's it, that would be known as a trapezoid. The next is a parallelogram, And ladies and gentlemen, a parallelogram is a shape similar to this. And a parallelogram has several characteristics, if you will. A parallelogram has several characteristics. Number one, in a parallelogram, as the name implies, parallel, opposite sides are going to be parallel. So for example, this side and this side, they are opposite, they're across from each other. These sides are parallel, as well as this side and this side would also be parallel. They are parallel to each other. That's what makes this a parallelogram. Besides that, ladies and gentlemen, these things are also true of all parallelograms. Opposite sides are congruent. Opposite sides are congruent. So for example, this side right here and this side right here are congruent, meaning they are the same size, as well as this side and this side. Those two sides are congruent. They are the same size. That's true of all parallelograms. The opposite sides will always be congruent. Finally, something that's true of all parallelograms is that the opposite angles will also be congruent. So notice this parallelogram right here. Notice that this angle and this angle are the same. They are opposite to each other. They are congruent. So if this angle right here was open to a degree of 65 degrees, then this one over here would also be 65 degrees. And also, ladies and gentlemen, notice how this angle and this angle are also opposite to each other. They are also congruent. If this was 110 degrees, this would also be 110 degrees. So yes. Now, considering parallelograms, we have three special types of parallelograms. Beginning with the rectangle. Yes, a rectangle, ladies and gentlemen, is a parallelogram, just like the one that we have right here. Or I could draw a few more. This would also be a rectangle. This would also be a rectangle, etc. So a rectangle is indeed a parallelogram, as you can see there by the markings that I put that down. Opposite sides are parallel and they are the same size. However, what makes a rectangle special is that it has four right angles. Notice these little boxes on the corners. Those always mean 90 degrees. So a rectangle has four 90-degree angles. That's what makes it a rectangle. So it is a parallelogram. Specifically, it is known as a rectangle because of the 4 right angles. Next, we have a rhombus. A rhombus. And a rhombus, ladies and gentlemen, again, is a parallelogram, but it is a very special parallelogram because not only are opposite sides parallel, not only are opposite sides the same, congruent, and not only are opposite angles the same also, but it also has 4 equal sides. Opposite sides are the same, and all the sides are actually exactly the same. So for example, if this was 10 millimeters, this would also be 10 millimeters, as with this and this. That's what makes this parallelogram a rhombus. The fact that it has 4 congruent sides, 4 sides that are equal. And that finally leads us to the humble square. The square, ladies and gentlemen, is a parallelogram. It's probably the most perfect parallelogram because opposite sides are parallel, opposite angles, everything is pretty much the same. In fact, a square has 4 right angles. They're all 90 degrees. And all these sides are the exact same length. That's what makes a square a square. So it's almost like if you put a rectangle and a rhombus together, that gives you a square. Now, it is by looking at a square and a rectangle that you can notice one of the most important aspects of a quadrilateral. And notice that if this is 90 degrees, and if this is 90 degrees, and if this is 90 degrees, and if this is 90 degrees, what's going to be the total measurement of the angles of a quadrilateral? Well, 90 plus 90 is 180. 90 plus 90 is 180. And if we add those two, that gives us 360 degrees. Unlike a triangle, in a triangle, the measurement of the interior angles was 180. But with a quadrilateral, here we have 360. And that actually makes perfect sense, ladies and gentlemen, because notice what happens whenever I cut a quadrilateral in half. Notice that now I have 2 triangles. Here's one triangle, this is 180 degrees. And here's another triangle that together is 180 degrees. So together they make 360 degrees. Now that is true for any quadrilateral. Triangle, triangle, both are 180. I could also cut it like this, 2 congruent triangles, both of which have 180 degrees within them. Same thing with this one. So yes, that's something that you need to know. The sum of the angles of a quadrilateral, when you add up all those 4 angles, it doesn't matter what kind of quadrilateral it is, you are going to get 360 degrees. Which leads us to our final point, which is consecutive angles. Consecutive angles are angles on the same side, meaning that if you were to cut a quadrilateral, or in this case, a parallelogram in half, consecutive angles would be the 2 angles that are on the same side. So in this case, these 2 angles are consecutive, and these 2 angles would be consecutive. If I cut it long ways like this, then these 2 angles would be consecutive, and these 2 angles would be consecutive to each other. And all you need to know is that when you add up consecutive angles, angles on the same side, they will add up to 180 degrees. When you think about it, that makes perfect sense because it's half of the angles of the parallelogram. And so if together they made 360, well, half of it should be 180. And yes, indeed, 115 plus 65 is 180. And the other 2 should be the other 180. Together they make 360. Why is that important? Well, let's suppose that I only gave you one of these angles. Let's suppose that you only knew that this was 115, and I was asking you, what is the measure of this angle? Well, you know that 115 plus that missing angle together should be 180. Therefore, 180 minus 115 should give you the value of the missing angle, and you can always figure that out. So as long as you know that this is a parallelogram, consecutive angles in this regard only apply to parallelograms. All right, I know that was a lot. Hopefully I wasn't going too fast. But with that in mind, ladies and gentlemen, I do want to show you just the first couple problems on Schoology. In fact, going into OneNote, we begin with number 5, and we're given this, and this is the first one from Schoology. It says, use what you've learned about rhombi, which rhombi is just a rhombus. Rhombi is plural for rhombus. So let's use what we know about rhombi to find the missing length and angle measure. Okay, well, we know that a rhombus is simply a parallelogram where all the sides are exactly the same. So this side is the same as this side, the same as this side, the same as this side, okay? And here it's asking, well, what is the measurement of BT? What does it mean by BT? Well, B is this point right here, and T is this point right here. Now, it is not the angle. You don't make an angle with a line. That's just the distance from B to T. So it's essentially asking, what is the distance from here to here? Well, ladies and gentlemen, it's a rhombus. The first thing that you should think about with rhombus, besides the fact that it's a parallelogram, is that all the sides are exactly the same length. So if from point B to this point over here, it's 10 millimeters, then this will also be 10. This will also be 10, and BT has to be 10 as well. How do I know that? Because it's a rhombus. They're telling you all the sides are equal. That's why the names of these shapes are so important, because they give you so much information. All right, now let's look at this right here. It has an M, and then it has like an inequality symbol, and then a T. That is not an inequality symbol. An inequality symbol would be like right in the middle, but no, notice how the bottom part is flat. Ladies and gentlemen, this means measure of the angle, and in this case, measure of angle T. In other words, we're not just looking at point T, but we're looking at the actual angle that you find at T. Well, how can we know this measure? Well, let's remember this is a rhombus, and a rhombus is a parallelogram, and we know that in parallelograms, opposite angles are exactly the same value. And so if this is 65 degrees, if this is a rhombus, which is a type of parallelogram, then T also has to be 65 degrees. Yeah, just like this angle up here has to be 115. Notice that they resemble each other. Notice how these two are obtuse angles and these two are narrow, acute angles over here. And so again, I'm simply applying what I just saw in my notes to this information right here. And so, ladies and gentlemen, hopefully this was helpful. I'll let you try the rest on your own. And with that in mind, I will see you next time.